Welcome to Unit 5, Lesson 9. What is a logarithm? Practice problems. Okay, for each equation in the left column, find the right column or an exact approximate value for the unknown exponent so that the equation is true. So what you have to do is go back to a log table, or the beautiful thing here is you just rewrite this. So let me show you how to rewrite A. So 10 to the y equals 10. So this is the answer. 10 is the answer. Y is the exponent. When we transform log, the base is the subscript. The answer goes next to the log, and the exponent goes on the other side. So now, in the calculator, next to the 7, when you hit the log, that's log base 10. They just write log. Log base 10 is log on the calculator. So all I got to do is hit log 10, hit enter, you'll get 1. So this is positive 1. Now, for B, hit log 20, and log is next to the 7. You get 1.3. And remember, they round to 4 decimals. So look at your calculator. It says 301029. And they got 1301. That's a little high, but whatever. They made an error. 301. They only rounded to 3 digits. Okay, that's what they're doing. They only rounded 3. When you don't know, round to 4 digits, because it's going to be important for the next answers. And sometimes on Delta Math, I'll ask you to do that. For C, we're going to hit log 2000. That's 3.301. For 900, should be a little less than 3. So just hit log 900, hit enter, get 2.954. And then finally, log 4, hit enter, 0.602. And 2 of them we did not use. Okay, how do we say this expression of words? What do we say? We say these words. Log base 10 of 100. The base is 10. X is the exponent equals 100 in exponential form. So this is called logarithmic form. And this is called exponential. And we've been dealing with exponential forms since Unit 3. We looked at Unit 4, exponentials. And then now we're going to logarithm. So now, what logs do is they count the exponent. This counts the exponent on 100. Base 10, what's the exponent that gets you to 100? And what's the value of this expression? The beautiful thing about log 10, all you got to do is count the number of zeros after the 1. If it leaves with a 1, just count the number of zeros. And this equals 2. Log base 10 of 100 equals 2. The base 10 log table shows us that the value of log 50 is about 1.699. Explain or show why that it makes sense that the value is between 1 and 2. So the log base 10 of 10 is 10, so it's 1. Log base 10 of 100 has 2 zeros, so it's 2. So log of 50 is in between 1 and 2. It's a little bit higher. It's not 1.5. It's a little higher, but that's due to the nature of the graph. I'll talk about that if we get to the graphing. Okay, here's a table of some logarithm values. And this tables I had to use when I was young. What is the approximate value of log 10 of 400? So basically, just look at 400. That's all you got to do. 2.6021. What is the value of log 1,000? It's 3. How do we know this is true? It's a whole number. It's exact. It's exact because it's a whole number. How do we know? Log 10 of 1,000 equals 3. It has 3 zeros after the 1. It starts with a 1. Just count the number of zeros. Because 10 cubed equals 1,000. Integer in, integer out. What is the value of log base 10 of 1 billion? Count the number of zeros. Equals 9. It starts with a 1. Starts with a 1, just count the number of zeros. Okay, a bank account balance, and you can read the rest. How many years will it take for the account balance to double? So it starts with $1,000 in it. So we want to know when it gets to 2,000. So what we're going to do is hit y equals 1,000, 1.08 to the x power. Don't put t into the calculator. Put x t theta n, which is next to the green button. And then hit second graph. Make sure your table is in ones. If you left it from the last lesson in 5730, you're going to have to hit second plus 712. And then hit enter. And then hit enter. And this will reset your calculator. You'll get the reset RAM thing in. Then put your calculator in. Every time you pick up your calculator, you should reset it. I forgot to say that earlier, so I'm just going to clear it. 1,000, 1.08, caret x. And so now all I got to do is scroll down and see when it gets to about 1,000. From 1,000 to 2,000. At year 9, when t equals 9, y is 1999. So it takes a little bit over 9 years. Okay, the graph shows the number of milligrams of a chemical in a test tube d days after it was first. Explain what the point 1, 2.5 means. It means after 1 day, because 1 is on x, so 1 day, it decayed down to 2.5 milligrams. So it went from 20 to 2.5. So we could get our decay rate and all that stuff, but I don't know if they want that. So 8 hours. If there are 24 hours in a day, if we divide this by 3, we get 8. So mark the point that represents, so 1/3 is our exponent. So 1/3 is our x value. So let's see, 1, 2, 3, 4, 5, 1 day. 1, 2, 3, 4, 5, 6. So 24 divided by 6 is 4. This is every 4 hours. Each line is 4 hours. 4, 8, 12, 16, 20, 24. 8 hours is 2 tick marks. So this mark right here. So we go to 8. We go over. So about 10. So why did I write a half here? I meant to write a third. Sorry, folks. There should be a third. And that lets us know that 10 milligrams was left. So that's our point. That was a lot of interpolation of the graph that we had to do, but we had it worked out. We could have did it by doing 20 divided by 2.5, getting this number, and then raising that to the 2 out of 6. Getting this number and then raising it to the 2 out of 6. We could have did that. So a couple ways we could have solved this problem. The exponential function takes the value of 10 when x equals 1. So the first thing I'm going to do, I'm going to draw a graph to help me see. So at 1, we're at 10. At 2, we're at 30, 20, 30. So at 1, we're at 10. At 2, we're at 30. Okay, what is the y-intercept? So we got to go back one jump. So we get divided by 3. So if it's tripling, going to the right, we got to divide by 3. So 10 divided by 3, that's not a nice number. That's 3 1/3. All right, so the y-intercept is 0, 10 thirds. What is an equation? So our start is 10 thirds times 3, because it's tripling, for x. Y equals, or f of x. So let's say f of x, because they say function, and to write it in function notation, we write f of x equals that. And there you go.